All right, let's get started. It's like herding cats here. All right, welcome to The Price is Right.
Okay. Right. Repeater update. So this last month been very busy working on proposal and design for New Hope. And some of the members may recall New Hope, and a lot of them probably never heard of it. Um, Back in the day, there was a radio station there, AM radio station established in 1939, and 4 towers were put up. And he put up the VHF and UHF ham band antennas on tower number 1. And we installed equipment up there, and we had some difficulty when they went to digital subcarrier. And so that switched over to keep it running. We went to APRS. Well, the station changed hands and it went to business broadcast, and nobody got the agreement that we had. Jack couldn't find it. I helped search his shop and records, and nobody could find it. Well, this last spring, there was a big storm came through. We had some strong winds, as we found out at Custer in Virginia. Well, that blew our cabinets over. Well, it also blew 3 of the towers. Now, these towers are about 350 feet high. So it was quite a calamity. Well, we got a phone call, actually, I think, or we got an email. I think it was you, Dave, right? It turned out we have a member of the club who hasn't really been in attendance very much. And he said, hey, thanks for the membership, rejoin proposal. And oh, by the way, I'm the director of engineering for KTNO. And it's a station that used to be Radio Disney. And our towers are down. And by the way, you have an antenna on Tower 1, and we're going to rebuild it. And we need to control the cost because it's very expensive. We're upwards of a little less than $500,000 to place it. We need to keep the same RF pattern that the FCC approved, which means we need that antenna back and the coax. Would you be interested? You can imagine what I said, right? But I needed to do a little research and went out there and took a look and got a tour of the station. And we had a group got together. We did some salvaging, got a bunch of awesome pictures of the wreckage. And we've been busy working to get a formal agreement with them. So it's Salem Media Group that owns KTNO. And they've got, 70 stations or so around the U.S. And so this is part of my efforts have been to diversify the capabilities of the club. There are tenants that pay, right? Cell phone companies. And we're below that, right? So they get priority. Well, the AM radio station has a public service part also, and they include some ham stations on some of their towers. They don't have a problem with it. So it's a totally different type of agreement. The purpose of the infrastructure is for radio, not for elevated water storage. So it's great. There's going to be a presentation after me by Dave where I've put together a design and we've costed it out, and Dave's done some procurements and some really clever scrounging and wheeling and dealing. And so there's some great news about maybe reestablishing our presence that we've been, off the air for years. I don't know how many years, Dave, 4 years ago or so. Yeah. So anyway, so it's pretty exciting. So I've been working on that, getting that ready. And so there's a prezo tonight on that. About half of the budget you saw. So we've got a lot of stuff that's already a Marc asset. We don't need to buy it, and we've had some donations. The microwave stuff, Tim gave microwave stuff. We've also got a donation from Encore Wire, $500 to help us out. So we're moving along. So I'm pretty excited about that. And as to the repeaters, they seem to be enjoying the auditor. Haven't seen any problem. I'm seeing the propagation improve. I'm seeing about the noise floor dropping about 5 dB in the last maybe 6 to 8 weeks. So that's great. I mean, let's enjoy it while we can. And with that, I'll pass it back to our MC.
Thank you, Ron. Ron does a lot of work for the club. It's a full-time job, I would say, and the pay's not very good. But we all have the benefit of his expertise and experience. All right. Speaking of that, the next slide. Yeah, we'll get into that here in just a minute. Okay, so we brought this up during the last general meeting, and part of our operating requirements or rules are that we also post this in our newsletter, and we bring it up again during this meeting for a final vote to a change in our bylaw. And this was the bylaw amendment motion that was in the newsletter, also in the last general meeting. And the only thing we are changing to our bylaws as we are removing the number 2, and we're not limiting the number of technical assistants that Ron can have. So I guess the question is there any additional discussion that we need to have on this change? Okay. Okay, so we have a motion on the floor to bring this back on the table. All right. We have to vote on that motion. Okay, yeah. All right. All right. Sid, second. All right. All in favor on bringing this back onto the table? All right. Any opposed? No, I didn't think so. Okay. All right. Thank you. So the rules may seem kind of silly, but we are a nonprofit organization, so we need to adhere to them. So that's why we do a lot of this legalism. And to me, I'm a very simple person. I just, here it is. What do y'all think? So, okay, we still need to go backward. We're not done yet. Okay, so this is again, this has been brought up. Is there any additional discussion on this before we take a vote? Okay. Can I get a motion to pass? Okay. Well, the motion's been made to back on the table, right? Okay. Just straight up. And they're Robert's rules of orders, and Robert doesn't know about them. Different Robert. Okay. Yeah, this Robert's rules of orders are a little bit more simple. Okay. All right. So yeah, let's vote on this. All in favor on approving this change to our bylaws? Okay. Any opposed? All right. I didn't think so. Ron definitely needs the help. Yeah. Yeah. If you're interested in a technical position to help Ron, I believe Sid and Dick are part of the committee for that, as well as Dave. You and Sid. I thought Dick was part of that. Now, Sid and Dick are part of the nominating committee. We'll get into that later. Everybody's got these fancy titles and stuff. I can't keep track. Okay, speaking of guy that's pretty fancy, Dave, I'm going to turn this over to you.
Yeah, this is going to be a fun ride. Okay, as we've been working through things at New Hope and Fairview, and we've talked in meetings about it, we've talked at breakfast, we talk on the repeater about it. It became very obvious to us on the board that we've not done a very good job of explaining to the membership what our assets are as a club with regard to sites. We did close to 10 years ago, but we've got a lot of new members since then. So we thought it'd be a good time to go through this, since we're going to be funding and work and everything that's going to need to be done. We thought everybody should understand why, where, and what the expected results will be. Ding. Okay, so as you might have read in my write-up, where we justified why Ron needs more than just 2 people to help him, I mentioned that we will soon be a 5-site radio club. These are all 5 of these sites. We've got Melissa, we've got New Hope, we've got 75 and 380, we've got Virginia and Custer, and we've got Fairview. Now, what I've got there in the smaller print that may not be easy to see at the back is I've given an estimate of how high each of those sites are and a brief description of what potential capabilities exist at each of those sites. Not necessarily what we have installed, but what could be there. So right now in Melissa, we have a 70 centimeter, it's about 170 feet above ground level. Now, for those of you familiar with the geography around here, while that may be above ground level, Melissa is quite a bit higher elevation-wise than McKinney is. So we're actually quite a bit higher there than most anywhere in McKinney. So 170 feet, we currently have installed there a 70 centimeter repeater and all of the associated accoutrements, feed lines, antennas, power supplies, etc. A 2-meter APRS digipeater. For those that don't know what APRS is, I got a slide here in a second. We'll do a brief overview because APRS is one of our assets. We thought it'd be good that you guys understood what it is we're doing with it. We're planning to install some cameras and microwave equipment there to allow the National Weather Service to be able to see what's going on the ground there in Melissa. New Hope is the site Ron was just talking about. It's one we haven't talked about in this club in a good while because while we had equipment installed there and it operated unattended for a long time, we didn't have access to it anymore. The owner of the site just ghosted us. And so we really couldn't get in anymore. We had almost we had mentally written it off as, oh, well, I guess we've lost that. And after the developments that Ron mentioned, it's no longer lost. It's back again. Yay. That site's pretty cool because the 2-meter antenna that's installed there, or will be installed, we hope will be installed there, was at 330 feet. So significantly higher than anywhere else. Today, what we have installed equipment-wise there is a 2-meter APRS digipeater. We did that as a mechanism to maintain our footprint there after we had moved our 2-meter repeater out of that site. We wanted to make sure that we still had a claim to be there. It was not a first spot. That was actually our third. Yes, first place that the club had a repeater was in the early 1980s, and it was at a guy named, what was his name? Jim Francis, I think. Keith Francis. It was at Keith Francis's home in Princeton. it eventually got moved to the water tower here at 75 and 380. At one point, I don't have a solid record of this, but I'm guessing early to mid 1990s, something went wrong there at 75 and 380, and the repeater was no longer working. They checked out all of the radio equipment. They couldn't figure out. There was nothing wrong with the radio equipment, so their assumption was either the antenna had gone bad or the feed line was bad. And they were getting ready to put a plan together for how to deal with that when Jack Selmeyer said, "Hey, I own this radio station in New Hope and happen to have this 2-meter repeater, capable antenna sitting on at 330 feet on a tower. And I've got a climate controlled building with power and a generator and everything. How'd you guys like to move your repeater out there?" So they just quit doing any work whatsoever at 75 and 380, picked up the repeater and hauled it to New Hope. And it sat there until, as Ron mentioned, they implemented this digital subcarrier back around 2008. So when that happened, we tried to troubleshoot that 6-8 weeks. Wasn't that the repeater didn't work, it's just that the sensitivity was gone. Basically, you had to be within 2 miles of it to be able to key it. It was horrible. Absolutely horrible. And so we fought it, and we just weren't getting anywhere. And so we were trying to figure out some way to get back on the air quickly. And so the thought came to our minds about, well, hey, we still have this footprint over here at 75 and 380. We weren't convinced that the antenna was actually bad. So we said, let's just go look at it and see what we think is wrong. Got out there, we put a TDR, or time domain reflectometer, onto the heliax and shot down there, and we found out, oh my goodness, there's a fault on the heliax 10 feet outside of our building. 10 feet. Don't have to climb, don't have to replace an antenna. We just replaced that section of coax, and suddenly the thing worked beautifully. So we grabbed the repeater from New Hope, hauled it to 75, 380, and we were back on the air. And that was when we said, okay, but we love the New Hope site. Do we want to abandon it? And the answer was no. And so we came up with the idea of putting an APRS digipeater there so we could maintain our footprint at the site. So that's kind of the history. The repeater moved from New Hope to 75 380 officially in December of 2008. We filed the paperwork with the VHF Society from a coordination standpoint around summer of 2009, which is about the pace that the VHF Society works. That what you wanted, Ron? All right. So at 75 and 380, we're at approximately 190 feet above ground level there. We do have 2 antennas and 2 feed lines at that site. Got a 2-meter antenna, which is a standard Decibel Products DB224 antenna. And then we've got a 70-centimeter antenna that, golly, how many loops does that have, do you think, Ron? 8? It's a small 70-centimeter antenna. So we've got that. And while we were working over there one year, we went ahead and said, just replace all the feed lines, because what had happened is the city of McKinney decided to completely remodel that water tower, and they went ahead and pulled all antennas and feed lines and everything off of it. And they volunteered to remount everything and pull all the feed lines for us for free. So he said, well, heck, while we're at it, let's just get brand new feed line. So we've got some top of the line feed line there at 75 and 380. The 2-meter is running with Times Microwave LMR 900. For those of you familiar, that's actually a couple of notches above what's required for that application. And then the 70-centimeter antenna is running with Times Microwave LMR 1200, which is what you would normally run if you were running in the microwave range of things. So we're actually overbuilt there for feed line. Then, as part of our trying to harden our infrastructure, we came up with the idea of creating an alternate repeater site for our 2-meter repeater. That was where 75 and 380 came to be. Not 75 and 380, Custer in Virginia. And this was about 2005, maybe 2006. We put up a 2-meter repeater on the exact same frequency as the repeater at 75 and 380, put an antenna up, ran new feed line, got it all installed and working, got with the VHF Society and told them what we were doing, said, hey, look, it's only going to be turned on if we have a failure at 75 and 380. So do we really need to re-coordinate? And the coordination guy for our region said, well, no. So it's recorded that it's there and we can run it, but we can't run it there permanently with our current coordination documents. The only antenna and feed line we have at that site is for 2 meters. And then I got a fifth site yet, Fairview. We've talked about Fairview a lot, but what we haven't talked about is the intended installation there. So Fairview is another water tower. I could not remember, and that's why it's not here. Do you remember approximately how tall that is, Ron? So approximately 170 feet, just like the others. So it's at approximately 170 feet. The intention is that we're going to run a 70 centimeter repeater at that site, and it'll have DMR capabilities. We will be set up with a 2-meter APRS digipeater. We'll put in camera and microwave links back up to Melissa. And while we're there, since the city was, we only wanted to go to the well once with the town to ask for permission for things. So we said, we think we want to put a third radio in there too. And that's going to require another antenna and a third feed line. And they are okie dokie with that. So we're going to have 3 antennas, 3 feed lines. So we'll have some capability there that we can tap at some future point should we need it. Any questions about all of this? These are our 5 sites. Yes. Just the antenna and feed line. And in actuality, the Melissa repeater started its life at 75 and 380 because we didn't have an agreement with the city of Melissa when the 70 centimeter repeater went in. Then one day, we found out one of our club members was pretty good friends with the mayor of Melissa. He said, oh yeah, sure, we can make that happen. So we did. And again, that's part of trying to diversify where our infrastructure is so that a single catastrophic failure won't kill everything we have. Yes, Joe. It has been damaged, and we'll go through that in just a minute. I've got a matrix. Love matrices. Any other quick questions? Yes. I'm not sure. The question for those online is, is it hard to separate our stuff at New Hope from the broadcast stuff? There's a pretty special piece of equipment called an ISO coupler that actually performs that isolation of our FM signal from their AM signal. And fortunately, throughout all of this, the ISO coupler was not damaged, which is great because those things cost like $7-8 grand at a minimum. So we felt very fortunate. Any more questions? Ding. All right, so Ron covered a little bit of this. I'm not going to spend a lot of time on it, but basically we thought it would be important to explain the types of things we think about when we're looking at new sites. We want to be sure that when we have a site, we have a stable relationship with our landlord because all of our sites are all owned by somebody else. We're just riding along. We want to have good environmental controls. In other words, we don't want it to be too hot, too cold, too wet, etc. Looking for geographically diverse locations. As you can see from that map, we've been pretty good at that so far. We want to be capable of accepting and supporting multiple technologies. So basically, repeaters, digipeaters, wires X, microwave, all of these fun things. We want to make sure that a site that we get can support more than just one thing, if possible. And then we get a bonus if we can deploy them all at the same time. So that's pretty cool. Repeater, digi, you know, wires X, everything all running simultaneously in one site. Really like that. And then it's an even bigger bonus if the owner is supplying all the environmental controls. And then finally, the big thing for us is the robust ability to access the site. You know, can we, you know, how do we get to it? Do we have to wait? How many phone calls do we have to make? Can we do it, you know, in the middle of the night? Can we do it on weekends? Does it have to be only during business days? All kinds of things like that we got to think about. Ding. This is kind of small, but we can make it available to anybody that wants it. But basically, you know, our 5 sites are in that left-hand column, and I just went through basically all the criteria and tried to explain in there how well that site met the criteria that we use. And they're not all perfect. They're really not. You know, frankly, you know, we're talking about New Hope right now, and it has some amazingly great stuff, but it's got a few things that are a bit of a problem. Site access is an issue. We got to call somebody, and we hope they're available, because you know what? They have a full-time job. They're not actually, their full-time job is not to let us into the site. So things like that are on here, but you know, we talked through the capabilities and all of this stuff, so that's all in there. The big thing, the items, the 2 places in red are where we need to make repairs. There's stuff damaged from the windstorms that have come through this last 12 months, and we need to fix them. Ding. Okay, so this is going to be my 2-minute overview of APRS. Who in here uses APRS? Who thinks they're really, really good at it? All right, very good. So APRS is something that is not as well known today as it was 20 years ago, but it's still exceedingly useful. If you notice this map up here, the map itself, this is just a view from aprs.fi. That's a website. You all can go there. And this is a map of McKinney and the surrounding area. And all of those little blue dots that you see are all weather stations. Basically, you have people that sit at home, they put a weather station up, and they link it into the APRS network, and the weather station then is reporting rainfall, wind speed, temperature, humidity, all of these lovely things every 5-10 minutes, and sending it out via the APRS network for people like us to go see whenever we want. So if you want to see how much rain happened, you know, down in Rice City, there's a guy with a weather station on APRS. You can go check that out. That's one thing that you get, but where APRS has really shown over the years is the ability to track the positions of mobile items. For those of you that may have worked the Balloon Festival uses APRS fairly heavily. Basically what they do, the balloon itself has what's called an APRS tracker. The APRS tracker has a lock into a GPS signal, and it is reporting its position back to the APRS network via a 2-meter radio via digipeaters. Basically, the 2-meter radios that are in trackers usually are pretty low power, some of them as small as like 100 milliwatts. And so how are they going to be able to cover, you know, to get that signal to a large area? Well, they really can't. And so in the same way that we have repeaters to try to make handhelds have a greater range, on APRS, we have digipeaters that receive the signals and then repeat them at a higher power over a longer distance. So right now the club is operating 2 APRS digipeaters. One of them has failed, which is the one at New Hope, but that's because the power is on the ground. The other one is in Melissa. And that repeater, or that digipeater, when we first put it in, was intended to be the wide area digipeater for the northern half of Collin County, because there was already a fairly good digipeater sitting down at the southern border of Collin County. So we just wanted to cover the northern half, because the northern half was dead. If you went up there with a tracker, the network would lose you right about the time you got to Melissa. So if you were trying to get into Weston or any of these other places, it just wasn't going to happen. So we put that digipeater up there, and that was awesome. Okay, 20 years later, here we are. There no longer is a digipeater in southern Collin County. I don't know what happened to it. I know the guy that owned it. I was surprised he put it up. It was sitting on a giant tower down there in South Collin County, and just one day it disappeared and hasn't come back. And it's probably been 7, 8 years since I last saw it working. So because of that, we believe it makes sense to do two things. Number one, repair the station in New Hope so that we can get that digipeater back online. And number two, when we put up the site at Fairview, we put digipeater capability in there to cover the southern half of Collin County with the wide area digipeating that it needs. And that'll make Collin County whole again from a digipeating perspective for APRS. I've got some stuff here. You guys can read it and research it later, but it's just some high level types of applications that you can do on APRS. Like I said, the position tracking is kind of the main one. Another one is, you can send messages from one APRS station to another. Frankly, those of you with Yaesu FTM 400 radios, you can go into the touch screen on your radio. You can actually type up a message and send it via APRS to another APRS station. They'll get alerted and say, oh, this is a text message for me. You can't put a lot in there, but you can send some basic info. I mentioned the weather station. We also have the ability, and we did this at Field Day. But it actually is. And the reason why it is when you think about it, like at Field Day, we wanted to make sure that people could see where we were. So Field Day, we actually plotted a stationary object on APRS that showed an icon with our club name right on this APRS map. So anybody that was wanting to find us, they could see it right there on the map, and it was called out that this is the McKinney Amateur Radio Club Field Day site. So you can do that. You can also do things such as plot out where digipeaters are. Now, this is kind of hard to see, but if you kind of look in the center, about a third of the way down from the top, you'll see a little green smudge, probably from where you're sitting. That's where the Melissa digipeater is. And we're plotted there. We're stationary, but every 20 minutes, we send a packet that says, hey, we're still here. We're still alive. That way, people that are using APRS can know where the digipeaters are that they can utilize. So, like I said, stationary objects, there's a lot of value to being able to plot those. Questions about APRS? I'm going to try to, over the next few months, try to put together a more in-depth presentation so you guys we can talk more about it. Yes, sir. It's possible that Fairview would be able to do that. We are looking to put in an internet link there. It would be the only one of our 5 sites with live internet. And so, yes, that particular site could absolutely house an iGate. Not surprising. I'm sure Gary had something to do with that. Yes. All right. Ding. All right. So let's get into what we need to do in New Hope. This is particularly important because, as Ron mentioned, Salem is rebuilding that site. We don't control that schedule. Salem has graciously offered that when they're rebuilding that site, all of the labor needed to climb the towers, mount our stuff, pull the cables, attach them to the tower. They will pay to do all of that. We just got to bring the stuff, but we got to bring it when they're ready. They've not told us when they're going to be ready. They actually told us back in early September. They said, "Oh yeah, we're going to be done by the end of September." Could be any day. This is kind of critical that we cover this now. So basically, all the towers are being replaced. So there are a total of 5 towers at that site. 3 of them, no, there's 5. Yeah, 3 of them collapsed. So they're replacing 3. One of them is the one that we're on. Salem absolutely wants us back. And they want us back in the exact same configuration we were in before it went down. For those that understand AM radio licensing, the FCC gets really, 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 really picky about the pattern of your signal when you're broadcasting. And the pattern of an AM radio station is affected by lots of small things. And if our antenna is not placed back in the exact same position with the same feed line that was there before, it will alter the pattern and cause Salem to have to go back and relicense. It's one of the reasons why they're being so nice about providing the labor. The things that we need to put in new antenna, new feed line, new connectors, new bonding straps. Got to put new weatherproofing material on everything. We got to come up with a standoff to be able to mount the antenna 24 inches off the side of that tower. We got to have the clamps to be able to attach the antenna to that standoff. We have to have it's a big list, and I'll show you the list here in a minute. But basically, we got to get all of that stuff. And then while we're there, there's some other things that broke inside of the building just because of age that now that we have access, we should go fix. Ding. So this is the list of stuff that we need and what each line item costs. I can go through all this, but frankly, just trust me, this is all that's needed, and there's probably a few things that me and Ron didn't think of. So far, the total comes to $5,571. As I said, there'll likely be a few things that we didn't think of, or maybe we didn't buy enough of. Ron and I were talking about this earlier. Might have run short on the number of clips that we need to attach the coax to the clamps that attach to the tower legs. Things like that. So the reason we're here today having this big discussion is to spend this kind of money. We need the approval of the membership. This is not something the board of directors can do on our own. Now, what I'm going to explain here, I think will make it feel a little insurance fund for just such a situation as this. And every year we have taken $400 out of the treasury and moved it over to this self-insurance fund. So it has grown from its initial start now to a balance of $6,181, which was a number we felt really good about in 2014 when we made the decision to do this. Because, when we kind of looked at it, we said, yeah, it's probably some of the most expensive stuff we'd ever have to buy would probably cost around that 6,000 range. So we were prescient or lucky, either way. But the club has already set aside the money to invest in these types of repairs. So don't think that we're pulling this out of the general fund. Questions about the money? Yes, Kiri. Yes, it's included in that $28,000 total. That $28,000 total is actually broken up into three separate accounts. We have the general fund, we have the self-insurance fund, and then we have the youth fund. Yes, sir. Yes. Have not had a chance to truly assess everything that needs to be done there, so we don't know. Oh, it absolutely is because the one at Virginia and Custer, we can do at our leisure. This one, we don't control the timeline. If we did, we might prioritize differently, but it's the realities of where we are. Any other questions about the costs or the inventory? Yes, Cliff. Yes. Dick. They are going to supply all of the labor. So that is, it frankly, Ron, check me on this, but I think if we had to pay for the labor to do this, we're looking at about $4,000 for the labor alone. Yes. There you go. So Salem is making this very worthwhile for us to do. All right. So that all being said, I'm not hearing any more questions about the money. I am personally going to make the motion that we spend an amount not to exceed $6,000 for the repair of the New Hope site. Tim Valens has seconded it.
I know it. All right. So the motion's on the table. It's been seconded by Tim. All in favor? Okay. Any opposed? All right. Motion passed.
Problem.
That'd be great.
Yeah, don't worry about it. And let me just preface this by saying that my email is good on QRZ. And I'm going to go through this very quickly. I'm just going to hit some high points. But all my slides, everything is available. If you send me an email, if you have any questions, I'm always happy to reach out and help. I sit down and answer all my emails over 2 cups of dark Italian roast coffee every morning. So by all means, if anything comes up, don't worry about it. Just write me then. All right. I was born upstate New York. Oh, by the way, greetings from Silicon Valley. Born in upstate New York, got my double E degree, electrical engineering degree in Ohio. Retired after working at several big companies and small startups. I love to play golf. I love to hike. I love to play music, but my geeky passion is POTA. Parks on the Air did 1,000 activations, which seems ridiculous. Since 2021, I actually invented the POTA Performer for myself when I first got started, and I'll talk a little bit about that. And and it went on from there. I have about 80,000 sideband QSOs on Parks on the Air. I still do it actively, a couple times a week when I can, but I have a lot of fun doing that. Like I said, everything I'm going to talk about is available at links. These are them on the screen. These are plans. I always distribute free plans for all my antenna designs to the amateur radio community. They're always at these bit.ly links. If you haven't distributed them there at the club, just send me an email and I'll send you whatever you want. I'm good at that. In fact, I have this antenna geeks list, and I put out a monthly newsletter where I introduce new antennas or I talk about revisions to old antennas. So if you want to get it on that list, just send me an email as well. But everything I do is for free, and I like to give back. That's my way of giving back. One of the coolest things that happened to me in the last year is at the last minute, one of my friends encouraged me to enter the QST antenna design competition, which I did, I think, 2 days before the deadline, and I did. I submitted my performer with my computer model, and it won an award. So I was really surprised, pleasantly surprised. I was really happy to see that. And in the September magazine, the QST magazine, they had a 5-page spread on the performer. Some of you may have seen that. And I just found out yesterday that this article won the cover plaque award for the September QST magazine, which means I get a plaque. It was the most popular, well-read article in QST that month. So I'm really proud of that. And I'm really happy that that came out. So let's get right into it. When I talk about antennas, I'm a geek. So I do look at the theory, but I only spend 5% of my time doing that. I discovered modeling about 4 or 5 years ago, computer modeling. I use 4NEC2. This is a fantastic tool to understand how antennas work. So I get to do it all in the virtual world before I get out into the semi-real world. In my semi-real world, we live on postage stamps here in Silicon Valley. This is my antenna proving ground, my backyard. You can see all the solar panels there. But this is where after I finish modeling antennas, I start playing with them in here, my backyard, and learn a lot that way. Reality versus virtual, there is a gap there, but I bring it into the real world. But most importantly, I always test my new antennas, ABC comparisons, what have you, with parks on the air. The hunters are my guinea pigs, and I love that because I get to try a new antenna and say, how does this sound versus this antenna, et cetera, et cetera. So that's my real world evaluation. And I'm very proud to say and humbled that as far as I know, I have about 15,000 people around the world using one of my antennas that I've designed for free. Because when you share designs for free, they spread around very, very quickly. So I'm really, really proud of that. And I'm going to keep designing antennas because I love to do it. It's a lot of fun. I have 3 design principles. First and foremost, performance. And I talk about something that commercial manufacturers rarely talk about, and that is efficiency. If you put in 100 watts from one of my antennas, I want it to be at least 90% efficient, which means you're going to radiate 90 watts. If you put in 10 watts QRP, I want you to radiate 9 watts. You think that sounds okay? That's typically double what most antennas are, portable antennas, and I'll talk about that in a little bit. Because these are all portable antennas, elegance, fast and simple deployment. I don't want to spend time throwing up complicated antennas that take a half hour to deploy. I want to be on the air in less than 5 minutes so I can start making contacts and have some fun out there in the field. So again, these are portable antennas, so fast and simple deployment. And because they are portable, I want to make sure they are very easy to pack and transport. So I put them around 5 pounds or less, keep them very convenient. And one thing I didn't realize when I first started, that there's a lot of HOA, restricted neighborhoods. We don't have those in Northern California, but a lot of guys want to just after dinner go out in their backyard, deploy the antenna, have some fun for 2-3 hours, then take it down. So that became a whole new segment of interest. And so I'm really pleased that a lot of HOAs are now using these antennas as well. So to talk about the performer, and I know I have about 15 minutes, I'm just going to keep this very high level, and I'm going to go quickly. So if you have any questions, send me an email. Let's talk about antennas. In fact, let's talk about a resonant antenna. You've seen this equation, impedance Z equals R, real resistance, plus J, square root of -1, forget that. X, reactance, capacitive or inductive. A resonant antenna happens when X, reactance, goes to 0. So when your antenna is resonant, no tuner ever required, your transceiver right here sees just 2 resistors in series to ground. That's it. That's what your antenna can be modeled as. And just like everything in life, there's a yin and there's a yang. There's a good and a bad. In this case, the good is the radiation resistance resistor. That's dependent on what kind of antenna you're using. For example, a quarter wave vertical is about 37 ohms. A dipole fed in the middle is about 70, 72 ohms. That's the good resistor. That helps you radiate electromagnetic waves in all directions. That's productive energy. Then there's a bad resistor. We don't like this one, but this one gets a lot of hams, and you don't even know it. You don't even know it. This is loss resistance, conductor losses in insulators, loading elements like coils and such. But most importantly, the biggest culprit, losses into the ground absorption and losses of the current, potential radiated current that goes directly into the ground, heating up the dirt. You don't want to do that. That's wasted energy. So when we talk about radiation efficiency, which is my #1 priority, performance, it's a long page of equations, but it comes down to one very simple one. Radiation efficiency is the good resistor over the sum of the good and the bad resistor. So just looking at this equation, if you want to get towards 100%, it's never 100%, but you want to move in that direction, you want to minimize your loss resistance. Make sense? Pretty clear? That's radiation efficiency, my friends. Very, very important. Now let's talk about the reality of what a lot of you do. You probably take your quarter wave vertical, you ground mount it, and then you throw radials on the ground. Oh my goodness, please don't do that. I'll tell you why. There was a brilliant guy, John Oppenheimer, much smarter than most of us, that actually went out and calculated. You can't measure loss resistance, the bad resistor, directly, but you can calculate it through some measurements in a very rigorous process. But he did that, and let's start. He said, okay, well let's start with a quarter wave vertical, ground mounted, throw out quarter wave verticals or quarter wave equivalent. So in this case, 2 quarter wave radials or 4 eighth wave radials, right? He says that's 85 ohms of loss resistance. And you say, Greg, 85 ohms? That's nothing. Well, wait a minute. Let's plug it in that radiation efficiency equation. The radiation efficiency equation for quarter wave vertical, remember, is 37 ohms. You put that over the sum of the 2 resistors, 37 plus 85, you get 30%. If you throw out 2 quarter wave or quarter wave equivalent radials on the ground, you're only going to radiate 30 watts, and you put in 100. That doesn't make sense. They say, oh, Greg, I do 4 radials, 1 at each compass point. Okay, what's 4 radials? 4 radials isn't much better. It's 37%. In fact, it takes at least 100 radials on the ground to get at least 90% efficiency. 100 radials on the ground to get 90% efficient. Remember, these are portable antennas, so that's not too portable, is it? Now, if you're QTH and you bury them, that's completely different. But portable antennas, that's not very efficient. I've got a much better idea, and let me show you what that is. Would you rather have to lay 100 wires on the ground or just elevate 2 radials? Because when you elevate 2 radials, the radiation loss, the loss resistance, so to speak, is only 4 ohms. Plug that in the equation. What do you get? 90%. 90% is 3 dB over those guys who are running 4 radials. I've got my antenna with 2 elevated radials. You've got yours on the ground with 4. Why do I sound twice as loud? Because I'm at 90% efficiency. You're at half that. I mean, like 30, 40% efficiency. It's amazing, isn't it? There's another brilliant guy, Rudy Severance, and he did an amazing experiment. This is something that he did back, I think he wrote about it in QEX, which is the technical journal of the QST. He did this amazing experiment, and I really respect him for doing this. He said, okay, let's get on 40 meters. Let's set up a radiator, a quarter wave radiator. Let's put it on the ground. Let's have on the ground radials at least 33 feet long. So he got that to resonance. No ground stakes, choke isolated. What happens? He took a field strength device, a very accurate one, went out about a full wavelength away, and he started taking measurements. And he said, okay, I've got 4 radials on the ground, 4 quarter wave radials on the ground. Whatever my field strength measurement is, that's what I'm going to call my 0 dB point. Okay? And then he went out to 8 radials. He went out to 16. He went out to 32, right around that inflection point. That's pretty typical. All the way to 64. And he found when he went from 4 to 64 radials, he increased his radiated signal through his field strength measurement by almost 6 dB. And that makes sense. You know, you complete the RF circuit, you can put more metal on the ground, less of that metal, less of that radiation goes into the ground, it goes out and gets re-radiated. That's important. That's good. He says, okay, now let's do something really interesting here. Let's take those same 4 ground radials, and that's the same y-axis here, right? That's the dB. And instead of putting them more radials on the ground, let's start lifting those 4 radials up or elevating those radials off the ground. He was shocked. He put them up, so the x-axis now is feet of elevation of those radials above ground. He found out just 6 inches above the ground, those same 4 radials that went from on the ground to 6 inches up, he gained 5 dB. 5 dB, just 6 inches off the ground. In fact, when he got out to 4 feet above the ground, he exceeded those 100 and whatever it was, those 64 radials on the ground, close to 6 dB. Bottom line, four elevated radials at a height of 4 feet are equivalent to 64 quarter wave radials lying on the ground. He proved it. Now, why does this happen? Well, you remember back in physics class, a capacitor, right? You have two plates of a capacitor. Consider the radial that's on the ground as one plate of that capacitor, and the ground is the other plate. If you remember, maybe you do, that as you move the distance further and further apart, capacitance is inversely proportional to the distance between the plates. So as you begin to move the plates, your capacitance goes down inversely very, very quickly. And all of a sudden, you don't lose all that current that's potentially radiating energy. Instead of going into the ground, it's now being fed back to the feed point to get re-radiated by the antenna. It's just like a capacitor. So look at it this way. You've got, consider this a dipole, a half wave. You remember when you took your test, resonant frequency, a standing wave is created, current and voltage 90 degrees out of phase. All right, so here's your current in red, and your current maxima is going to be in the middle. Here's your voltage in blue, your voltage minimums in the middle. What's happening? Well, as you move further down the line at the ends, you have less and less current, but you have more and more voltage. If you ever touch the end of a dipole when someone's transmitting, like I did one time, you get a little spark. It's not pleasant, but you get a little spark. But what radiates, current or voltage? Current radiates. So where is your maximum radiation point? That's at the center of the half wave. All right, so pretend this is your dipole. Now let's turn it into a quarter wave vertical. Quarter wave vertical, it's basically just this half to the left. Let's just pretend that's what it is, and let's move it up 90 degrees. So you have your quarter wave vertical here, and here's your radial over here. Remember, they always say your radials are the other half of your quarter wave vertical. When this radial is on the ground, and that feed point is pretty close to the ground, that's your current maximum, which is your radiation maximum, what's going to happen? All that current is going to try to radiate energy, electromagnetic waves, but it's going to go into the dirt because this radial is laying on the ground. That's why you don't want to do that. However, let's say you have an off-center fed half-wave antenna instead of a quarter wave, or even better, an end-fed half-wave. Now, all of this becomes the radiator, and this little piece becomes the counterpoise, or in an end-fed half-wave, it's even less than that. Because you have far less current at that point in the half-wave diagram, you can keep it closer to the ground. I like to keep my quarter wave verticals about 4 feet above the ground because that's your maximum radiation point, the feed point, maximum current. For an off-center fed or half-wave, a foot, at least a foot, 2 feet would be ideal, but you can take your little counterpoise and droop it down to the ground. Why? Because there's hardly any current there that gets absorbed into the ground. That's why it's okay to do that on a half-wave antenna, but not a quarter wave. All right, so how does this lead into the performer? It's real simple. Let's talk about it. So when I went out to POTA a few years ago, and I started playing around with my antennas, and I started working with hunters, they said, I kept getting these people saying, how come you sound so much louder than everyone else? 3 dB louder. Why? Because I designed this antenna to have just 2 elevated radials, which can either be 90 degrees apart for some directivity or 180 degrees apart opposite each other to have omnidirectional. You can put it on a tripod or you can put it on a PVC mount. This is the one that that won an award in the QST contest because they really love the elegance of the PVC tube, assuming you can put a spike in the dirt. But they really like that. It's designed to be very lightweight, very broad-banded, excellent SWR. The fundamental components of it are really simple. When I design these, I want to make sure most of this stuff is probably existing already in your ham radio stuff box. So I wanted to keep it easy. So the most important thing is I used my 4NEC2 Pro computer model and my field testing to determine the radial lengths for each of the bands from 6 meters out to 20 meters. And what I did with the design is to determine in inches how they could resonate at the center of each band. Because I like sideband, so I go to the upper part of the band. Other guys like digital and CW, they go to the lower part. So what I did is I designed this antenna with these fixed radial segments. You don't have to change these. Just build it the way I have in the PDF, and you will resonate at the center of the band. And you use your telescoping whip as your variable. So these are fixed. This is your variable. It's real simple. And notice I have it up. I say 52 inches is my favorite, but at least 4 feet would be great. Always, 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 A, B, C. Always be choking. Don't turn your coax into another radial, because then you get common mode currents, you get RFI, you get screwed up impedance, radiation patterns, everything's a mess. So each one of these, for example, my model said you need 43 inches of 2 elevated radials to resonate on 6 meters. You need 80 inches on 10 meters. So rather than having a separate wire for 10 meters, I just went incrementally another 37 inches. And that's how I got to 10, and so on all the way out to 20. Now, how do you change bands? It's real simple. I had this epiphany one day. All I needed to do was come up with a 3 to 4 inch non-conductive segment. I use paracord. A lot of guys use weed whackers. Another little segment that you put in the radial line between the two bands that you want to operate. So your antenna here, let's say you want to operate on 10 meters. Your antenna here will see the 6 meter segment, the 10 meter segment, and then sees the non-conductive segment and goes, oh, I guess we're done. So therefore, it doesn't see the rest of the radial line. So you don't have to move the stakes every time you change bands. It takes me 32 seconds to change bands. I just kind of jog out to the antenna, move the non-conductive segment, adjust the whip, and I'm done. It's fantastic. It comes on a tripod. You can see, for example, I love Muller clips. That's one of my favorite little tinker toys for antennas. I combine both elevated radials into one Muller clip. I just clip it to one of the screws on the mirror mount, and I store my little non-conductive segment at the end so I can move it. Here it's set for 20 meters, but I can move it up for 10 or whatever other band I want to work on. Here's the one that comes on a PVC tube. I show you how to build this in the PDF. I just have 3/8 by 24 hardware at the bottom to go into a spike or even a small tripod if you don't want to go into the ground. And at the top, I have a coupling nut with a nice little rod to hook to the mirror mount. There you can see the coupler for the radiator, the telescoping whip. There's the choke. It's already attached. So I just pull this out of the car, stick it in the ground, attach the coax, the whip, and the radials, and I'm ready to go. It's that quick. Make sure when you cut your radials, you indicate which band they're for. You don't want to get them mixed up. You always want to put them in the right order. I use spade connectors to interconnect the segments. A lot of guys use other kinds, whatever you want. It's good. In my PDF, I show you the spade connectors I use. You got to build your little non-conductive segments. And I roll them up in a nice little loop with a Velcro strap, easy to carry to a picnic table. Or if I go in my backpack, I put them on a little kite winder with my Rig Expert stick, my Byberry multi-tool, and I use the Chameleon M coil for 40 meters. I love that little thing. It's fantastic. I also have a portable version, which looks like this. And this is what I use when I go backpacking up in the hills. This is my ICOM 705 backpack, where I keep everything stored in here. And you can see the entire antenna just fits right in the side pocket. And I show you how to build that too in the PDF. All the computer stats, the model stats are in there. Bottom line, efficiency over 90% across all the bands. Low SWR, very low reflection coefficient. The lower the better. That's really good. If you have your radials at 90 degrees, you get a little bit of gain. You get on average a 0.4 dBi gain between the span of the radials. Most quarter wave verticals are -1 dBi. So this is about a dBi and a half of gain between the span of the radials. So you can point them in any direction you want if that's what you want to do. With a great front to back, about 3 dB front to back. Takeoff angle about 24 degrees and a very nice beam width about 44 degrees. The model produces these amazing graphics. Here's the SWR reflection coefficient. You can see the radiation pattern, but I just love this stuff because I'm a geek. This is the side angle of the radiation with the two elevated radials at 90 degrees. You can see how it kind of pulls all the radiation from the back to the front and gives you some directivity for this little antenna. But this is the real world, folks. That's just the model. This is the real world. Look at this amazing bandwidth. These were pictures I actually took about 3 years ago, one of my first activations. extremely broadbanded, very low. Look at the entire 15-meter band, 1.2 or better. And by the way, if you've got an SWR of 1.5 or lower, don't use a tuner. You don't need one. All the bands, though, give you very broadbanded performance and a low SWR. If you want to put your radials 180 degrees apart, here's the difference. That's 180 degrees in blue. It's an omnidirectional antenna. This is the radials at 90 degrees. And you can see the difference right up here. You get some more regional, this is why it's so popular for POTA. You get more regional radiation between 30 and 60 degrees, and you even get some NVIS. That's why some ECOMS groups love to use this antenna, because you get some radiation up past 60 degrees, 60 to 70 degrees off the horizon. It's pretty cool. If you don't want to build one, you can buy one. There's a guy that runs a manufacturing company and he puts these on Etsy. These are very, very high quality. He sold 50. He got all 5-star reviews. He sells the radial sets. He sells his own spikes, which are better quality than Chameleon and a little bit cheaper. He also just started selling my one of my half-wave antennas, the Challenger, which is probably one of my fastest growing antennas. It's all on Etsy. Just look up J Systems. J Systems. Go to his store and you'll see all those. I also just signed a deal with ABR. If you want to get 15 or 10 to 20% discount on any ABR cable, just put in my call sign at checkout, and you'll automatically get 10 to 20% off your entire order, depending on your order amount. So this just happened this week, so I'm really happy about that. I've got other antennas halfway, but my time is up. So I'm going to say I've got the Challenger antenna, which is the off-center fed half wave, and also the Dominator, which is the end-fed half wave, all using a telescoping whip. And there's a lot of stats to see inside of the PDFs, but you can look those up when you download those. Bottom line, if you want to get on my geek list, send me an email and I'll add it. All of these links, though, will always stay same. Even if I revise the plans underneath, you can still use the same link, and I always provide them for free to the amateur radio community. Done. 2 minutes late. How's that? You're all muted, so I can't hear can't hear anything. Did I meet your time commitment? I can't hear anybody.
How about now?
There you go. I can hear Sean now.
Greg, can you hear me?
Yes, I can hear you now.
Over there?
Yes,
All right, which microphone are we on?
just speak in this direction.
All right, Greg. Hey, I appreciate you being out there. Hey, I appreciate your positive demeanor. I know I've had a QSO with you actually
Yeah.
a year ago.
Yeah.
You will put a smile on every ham's face that talks to you. Jerry, I know you've had a QSO with him too.
Yeah.
Woohoo. And
Woohoo!
so thank you for doing that. So I think I've got a question. You have a lot more that you could share with us. Are you available to present at our next club meeting? Because tonight we had a lot of business to cover.
Yeah.
Our club meeting is November 11th. I don't want to put you on the spot, but if you're available to do this,
No, I already got something on that night. I've got my little calendar over here. It's probably going to have to be into next calendar year. I hate to say that, fellas.
no, that's no problem. But I can tell you this, we definitely want you back so you can do a full presentation.
Yeah, well, that was 60 minutes worth of stuff in 30. So I apologize for going fast, but I hit the high points.
Okay.
But by all means, I'm accessible via email. So send me an email. I will read it and I'll respond the next day. I promise.
Okay, Greg, I appreciate that. We will definitely be in touch. Thank you very much.
All right, fellas. I'll let you go. I'll let you close up the meeting, and I have to go eat dinner. Oh, thanks for the heart. I appreciate that. Okay, bye-bye. See you from California.
What?
This is the one that Roger uses. I didn't realize it. This is the one that Roger brought to